In this mechanics video we have a 15 kilogram mass initially at rest on a rough horizontal surface of coefficient of friction 3/5. This 15 kilogram mass is connected by a light inextensible string over a light smooth pulley to a 16 kilogram mass which is initially at rest on an inclined slope at 60 degrees to the horizontal, and the coefficient of friction of the inclined slope or plane is 1/4. Because this pulley is smooth, we can ignore any friction between the string and the pulley. When the system is released from rest, there are two tasks to calculate. Firstly, the acceleration of the masses, and secondly, the tension in the string. On the second diagram, all the forces and component forces will need to be shown in order to find the answers to the questions A and B. So starting with the 15 kilogram mass, its weight will act vertically downwards of a magnitude of 15g. Because it's resting on a surface, there will be a normal reaction perpendicular to the rough horizontal surface, and I'm going to denote that by R1. The 15 kilogram mass will be moving to the right, so in this light extensible string there will be a tension, and because it's moving to the right, the frictional force will always oppose the direction of motion, so the frictional force will go horizontally to the left, and I'm going to denote that by F1. For the 16 kilogram mass, because this is one string, the tension in it here will be the same as the other side of the pulley, so that will be capital T again. There will be a normal reaction of the inclined plane on the 16 kilogram mass perpendicular to the plane, and I'm going to denote that as R2. Now the weight of the 16 kilogram mass, i.e. 16g, needs to be resolved into two components, one parallel to the plane, i.e. in this direction, and this will be the weight 16g sine of the angle that the plane is to the horizontal, which in this case is 60 degrees. And perpendicular to the plane in this direction, the component of the weight will be 16g cos 60 degrees. Now because the 16 kilogram mass is going down the inclined plane, the frictional force on it will oppose that direction, so it will be going upwards, and I'm going to denote that as F2. So on this diagram now we have all the forces and components of forces that are required to solve this problem. So for part A, firstly, for the 15 kilogram mass, the first thing to do would be to resolve vertically. This is a double arrow because the 15 kilogram mass is not moving perpendicularly to the rough horizontal surface. So we have R1 acting upwards, and this must be balanced by 15G. Now, the equation to use to find the frictional force is F, the frictional force, equals mu, the coefficient of friction, times the normal reaction. So therefore F1 will equal the coefficient of the rough horizontal surface, which is 3/5, times the normal reaction, R1, 15G, and that gives 9G newtons. Now resolving horizontally to the right, because the 15 kilogram mass is moving horizontally to the right, we have T, take away F1, which is 9G. So that's the resultant force acting to the right, and that's going to equal MA, mass times acceleration. So that's going to be 15A. And I'm going to denote this equation as equation 1. Now for the 16 kilogram mass, resolving perpendicular to the plane, i.e. in this direction. Again, it's a double arrow because the 16 kilogram mass is not moving perpendicularly to the plane, only parallel to the plane. So here R2 will be balanced by 16G cos 60 degrees. And this equals 8G newtons. Therefore, F2, the frictional force F2, will equal mu, the coefficient of friction for the inclined plane, which is 1/4, times R2, which is 8G, and that's going to be 2G newtons. Now resolving in this direction, because the 6 kilogram mass is going downwards parallel to the plane, we have 16G sine 60 degrees, take away F2, which is 2G newtons, take away the tension, which is T, must equal MA, 16A. And this I'm going to denote as equation 2. On adding these two equations together, equation 1 plus equation 2, this leads to 16G sine 60 degrees minus 9G minus 2G equals 31A. Because when we add these two equations, the tensions will cancel out. Now working the left hand side out, using G as 9.8 gives 27.99, equals 31A. Therefore the acceleration of the two masses equals 0.903 meters per second squared. Now to find part B, the tension in the string, it's probably best to use equation 1. So rearranging equation 1 gives T equals 15A plus 9G which equals 15 times the acceleration just worked out, which is 0.903 plus 9 times G, which is 9.8. So to three significant figures, the tension in the string is 102 newtons. Again, I have created a few of these mechanics videos recently. Hopefully, once again, you found it interesting and informative. I will be producing some more in the very near future. Thank you for watching this video.